All right, so we're going to quickly look at how to go from our regular formula of future values for an annuity. So this one over here on the left, where we've got A equals M, which is the amount of money that you're investing or the regular payments that's happening, and turn it into something like the one on the right here, where we're working out what the regular payments and stuff are based off a future value that we have in interest. Now, this is going to be very, very useful because the left-hand side is great because if I know how much I'm investing and I know the term, I can work out how much we're going to have to end up with at the end, or how much my goal is at the end. Versus the one that's on the left, if I have a goal in mind and I want to know how much the payments are going to have to be, or the regular intervals that I'm going to be placing in or investing every term, I'd need the one on the right. And it'd be annoying if we had to rearrange going from the left-hand side to the right-hand side every single time. So what we just do is denote both of these to memory, or look off a formula sheet and go off using these separately. The problem is there may be a time where, let's say, the left-hand side is present, but maybe the right-hand side isn't present. And we need to know how to get from that left-hand side to that right-hand side, because working out those regular intervals is going to be useful to us. So that's what we're going to do. We're going to work with this left-hand side and hopefully rearrange to get to the right-hand side over here. Now, it looks scary because there's a lot of stuff that's there and a lot of stuff to move, but we're just wanting to try and isolate M all by itself. And M is already right next to something that's pretty easy to move. It's times by everything that's in that brackets. Now, just because everything is quite complex on that side doesn't mean that I can't move that whole thing onto the other side of the equation, which is what we're going to do. So at the moment, we've got M times by all of that stuff. So if we go and divide by that whole brackets of 1 plus I to the power of N, take 1 divided by I on both sides, we're going to actually be able to move that onto the left-hand side. I'm going to show that on the next step because otherwise I'd have to write that out a billion times. So on the right-hand side, we're left with just M. And we've got equals everything that would be on the left-hand side, which is A, which I'm going to do like this instead of a fraction, just because I'm going to be one step ahead of what we're going to be doing. We're going to have A divided by everything that was on that right-hand side, which is the whole brackets, which is 1 plus I to the power of N, take 1, divide by I. Now, it doesn't look great. It's not what we had on the right-hand side to start with yet. So we're going to have to try and do another step before we keep going. And that step is going to be what we know we can do with fractions, and fractions are very powerful things. The reason why I've got to divide by here is because there is a rule where we can change that to a times by if we flip this fraction. And I'll do a quick jot down here in a different color, just a regular example that we would normally do. Let's say it's 6 times by 2. 6 times by 2 we know would be 12. Nice and easy. If I think about it as a divided by instead, if I was trying to get the same answer, I wouldn't be able to divide it by 2. I'd have to divide it by something else. So if I have a look at 2 as a fraction, 2 on 1, I'm able to go and change everything to the other operation if I decide to flip that other side. So if I said 6 divided by a half, and I did that on a calculator, it turned out to be 12, just like 6 times 2 would be 12. So if I'm doing that, switching my operation and switching the order of those fractions, the numerator and denominator, I'm able to keep the same ratio of the same answer. So going back to what we've got over here, I'm allowed to change A to a times by instead of divide by if I flip that whole fraction. And if I flip that whole fraction, I'll keep the brackets there, I is going to be on the top because the denominator and numerator are flipping, and the numerator drops down, and I'll have the 1 plus I to the power N, take 1 on the bottom, all equaling M. Now, if I want to put that obviously into a nicer looking nicer looking format, we would be ending up with what we normally have, which is that one up there. We have the A, we take away the times by, we put the M on the left-hand side because we like everything on the left-hand side. And you'll notice that we've got exactly the same thing happening there. It's just a matter of trying to remember this rule that's down the bottom here. As long as you're remembering that you can change a times by to a divide or a divide to a times by, as long as you're flipping that fraction, you'll have a nicer and easier looking formula than this bit, this middle step, which is what most people should be able to get to, is this middle step, but it's a little bit more complicated and might have a little bit more room for error. Hopefully that was helpful to you.